Now that we've learned how to solve quadratic equations, we can actually work with some of applications that would involve the use or the need to solve a quadratic equation to answer whatever question we're asked. The problems that I'm going to give you, I'm just giving you a rough sample of questions. We're looking at more, don't focus when we're doing this, don't focus on the specific examples. Think about the big ideas. That when you are working with applications, you always want to look at big ideas. You want to work your way through the information. Try to figure out what they're telling you and then how you're going to use what they tell you to create an equation and then somehow solve that to then use the bound information to answer the question. As most of you know, when you're working with applications, it's the setup that's the hard part. Once you have it set up, once you know what equation you're trying to solve, then as long as you're okay with solving equations, that's the easy part. So really focus on keeping an open mind about how to do the solving and listening to what I'm saying about, some of the strategies that you can use that will hopefully help you, with other types of problems. So reading this, we have the length of a rectangle is 1 inch less. I'm going to keep my hand in here so hopefully it focuses. 1 inch less than 7 times its width. If the area of the rectangle is 50 square inches, find the dimensions of the rectangle round to the nearest tenth of an inch. So one of the big strategies that you need to use when working with applications is to not focus on the question that they're asking. Your focus needs to be on the given information. Okay, so the information I'm given is that I'm dealing with a rectangle. I'm also given some information about the lengths and the widths. So I like to start, if it's talking about a rectangle, I make a picture of a rectangle. I'm also given a relationship between length and width. And when I'm given a relationship between two different things, it makes it very easy to work with. I can just work in one variable pretty easily. And then I want to write expressions that represent the unknown length and the unknown width. So the length, I'm told, is 1 inch less than 7 times the width. So information about the length is given with respect to the width. So I don't work in L's and W's. I find people that do tend to kind of get confused. I just say I like to stick with X's if I can, or just, some basic generic variable, and not try to get specific with lengths, widths, yada, yada, yada. So I'm just going to say, all right, I'm going to let X represent the width. And once I have something for width, then I can go ahead and write an expression for length. The length, I'm told, is 1 inch less than 7 times this. So 1 inch less than 7 times x is 7x minus 1. Please note, if you write 1 minus 7x, that is not correct. It is not the same thing. Just thinking about subtraction, if you have the number 2 minus 3, that's negative 1. Or 3 minus 2, that's positive 1. When you're dealing with subtraction, subtraction is not commutative, so you do have to pay attention to order. Okay? So again, focusing on the information. So I'm told I'm dealing with a rectangle. I have addressed that. Was given information about width and length. I have addressed that. And also, I'm told that the area of this rectangle is 50. So I want to address that as well. And actually, I can then, when I address that final bit of information, then I can take what I have here, and actually I'll end up writing an equation. Area of a rectangle. When you're dealing with rectangles and the area of a rectangle, that is always found by multiplying length and width together. So if we multiply this length by this width, whatever they may be, we should get a product of 50. Length times width, width times length. So if I multiply the 7x minus 1 by x, we typically write it with our monomial factor first. So x times 7x minus 1, that area is 50. So now I have an equation, and that's what you're going for always. You should never try to start with an equation. Your goal is to work towards an equation. So working through the information, and then hopefully once you've done that, then you can get to a point where you have an equation or something you can solve. So when we solve this, we're going to find out what x is. Okay, so let's solve this equation. So I'm going to distribute my x. I've got 7x squared minus x equals 50. The equation that I have is has this x squared, so it's a quadratic. So I know if I'm solving a quadratic equation, either trying to solve by factoring or using the quadratic formula, I'll want it simplified equal to 0. So I'm going to go ahead and subtract this 50. So I have it simplified equal to 0. So I've got 7x squared minus x minus 50 equals 0. And so now I've got this quadratic equation to solve. Looking at this, there is not a quick factorization that comes to mind. So instead of trying to factor, I'm just going to go ahead and solve using the quadratic formula. So if I do, I have a is 7, b is negative 1, and c is negative 50. These are the values I would use in the quadratic formula. So I have x equals, opposite of b is positive 1, plus or minus the square root. B is negative 1 squared minus 4 times 7 times negative 50 all over 2 times 7. So taking the discriminant and substituting that into my calculator, the negative 1 times negative 1 is positive 1. So I have 1 minus 4 times 7 times negative 50. I'm doing this on my calculator, and you can do it on yours as well. And when you do, you should end up with 1401 for the value of that discriminant. So we have 1 plus or minus the square root of 1401 all divided by 14. So when I'm looking at this, my 1401, I think, oh no, I don't even want to try to simplify that root. But luckily for us, we were asked to round our answer to the nearest tenth of an inch, which means that I don't have to worry about looking for an exact solution, so I don't need to worry about trying to simplify. I can simply punch these numbers into my calculator to get a decimal approximation for this value. So inputting, I would suggest that if you have this calculator, just use your fraction key. So type in the numerator. So we'll have 1 plus the square root of 1401 over 14, and also 1 minus. So if I do the 1 plus the square root of 1401 over 14, and if I hit enter right now, oh, well, it did give me a decimal approximate. If it hadn't, I could have hit these double arrows here. So the 1 plus, that's approximately 2.7. Sorry, can you see this at all? And then I'm just going to go up and highlight, hit enter, and then it just puts it back in, and then I can change that plus to a minus and save myself a little work. So we get positive 2.7 and negative 2.6 as the approximation for these values here. So x is approximately 2.7 or negative 2.6. So coming back to what x is what I use to represent the width. Width is 2.7, width is negative 2.6. Negative 2.6 doesn't make sense. Okay, you cannot have a negative width. So it can't be that x is negative 2.6. It must be that it's approximately 2.7. So now, going back, so we found that the width is approximately 2.7 inches. And now I'm going to go back and see what I was asked to find. It said say find the dimensions. So I'm almost there. I found the width. Now I just need to find the length. And we know the length is 7 times the width minus 1. So our length is going to be approximately 7 times 2.7 minus 1. And 7 times 2.7 minus 1, we get approximately 17.9. Okay, and you know, depending on the book you're working with, I mean, this is really not ideal that you would take a rounded solution to then find another. You would really want to take this exact value, do 7 times that minus 1. But the book that we're working with does, you know, have us take this rounded value and find the length. So it's not my preference, but that's what we're working with, so that's what I'll tell you. So the length is about 17.9 and the width is 2.7. And I just want to caution you that if you're trying to check your work, if you multiply 2.7 and 17.9 together in the hopes of getting 50, it's not going to happen, because obviously this is an estimate. This is an estimate, so when we multiply this estimated width by this estimated length, we aren't going to get the exact area of 50, we're going to get an approximate. So it should be that if I multiply them together, that I get a value that's close to 50. And when I did, I got, can you see, maybe? Sorry, I'm trying to adjust it. No, it's fuzzy. It's approximately 48.33. So I do get a value that's close to 50, but because I am multiplying an approximated width by an approximated length, I'm not going to get exactly 50. I'm just going to get a value that's close. And so now we've answered the question, and we can move on from there. Okay, so the next one, a kite is in the shape of a triangle. The base of a kite is twice its height. If the area of the kite is 256 inches, we want to, sorry, let me put my hand in here, find the base and the height of the kite. Okay, so again, we're not focusing on the question, we're focusing on the information. So first bit, we're dealing with triangle. So let's make our triangle. And you know, don't try to just make a triangle. Don't try to say, oh, should it be isosceles, equilateral? We don't know. We don't really care at this point. Sometimes we would. And if we did care, it would be specified somehow. But we don't, so we're just making a triangle. We're also told that the base of this kite, or the base of this triangle, is twice the height. So I'm going to somehow talk about that algebraically. So height is here, this is height, this is base. This is twice this. So if I let x be the height, then the base is going to be 2 times that. Okay? So I've addressed the information I was told about the base and the height, and now I need to address what it says about the area. Told that the area of this kite is 256. And so to be able to address it, I have to think, okay, this is area of a triangle. So how do I work with area of a triangle? So you're going to have to pull some of your geometry, you know, some of your geometry knowledge into this. The area of a triangle is always base times height divided by 2, or 1/2 of base times height. I tend to use base times height divided by 2. Either way works. So it should be then, if I take the base, which is 2x, and I multiply the height, x, divide that by 2, I'll get the area, which I'm told is 256. Now I have an equation that can be solved to find x. Okay? Simplifying my numerator, I have 2x squared over 2 equals 256. Now in this case, you know, 2 times x squared over 2, I could cancel these 2's out. And or if I had several terms in the top and they were all divisible by 2, I would go ahead and simplify that way. So here I've got just one term, but let's say I had something like, I don't know, 2x squared minus 4x plus 2 equals 256 all over 2. I could simplify the left-hand side and just do all of these divisions, okay? I don't. I've got this, so I can just go ahead and cancel those out, and I have x squared equals 256. I can then take the square root of both sides, and I get x equals plus or minus the square root of 256, which is 16. So that's 16 or negative 16. X is what we use to represent the height, and you can't have a negative height, so the height must be 16, and therefore the base must be double that. 2 times 16, we get 32, and this is inches. Okay? When you're working with this formula, this area of a triangle, this is one way to address it, and in this case, this would be the easiest way to solve. Another way to solve, which you would employ, you may want to employ in other situations. Here, let me erase this. If we have 2x squared divided by 2 equals 256, another option is to start by getting rid of this divide by 2. And that's usually what I would do if I had in my numerator several terms that all were not divisible by 2. I would take this method for solving. So to get rid of this divide by 2, you can just start by multiplying both sides of your equation by 2. That cancels that, and you have then 2x squared equals 256 times 2 is what? 512? And then we can work to get just something squared equals a number, so we can now divide by this coefficient of 2, and we get back to that x squared equals 256. And that's just cyclical because of the nature of this setup, the nature of this equation that we're working with. But just know that, it's also an option to go ahead and multiply both sides by 2. So if I had something like 2x squared plus 3x equals equals 256, then I would start by multiplying both sides of that equation by 2. That would be the easiest way to go about solving that quadratic equation. If you have questions about that, let me know. If you come to something in your homework that's kind of funky in terms of solving, we can talk about it more. So anyway, based on that, all of that, we found that the height is 16 and the base is 32. Okay? Last example here. George is casting a shadow on the ground. George is 2 feet shorter than the length of the shadow, and the tip of the shadow is 10 feet from the top of George's head. How tall is George? Okay, so let's just make a picture. So here's George. And George is casting a shadow. So what you need to do is you need to think about what you know. So if he's standing on the ground and he's making a shadow, it's because the sun is somehow behind him, right? And the sun's rays come down, and George's body will block those rays, so this part will be dark, right? So that's how that shadow gets formed, because his body is blocking the rays of the sun, which is then causing this to be dark or causing a shadow. So we have George, we have his shadow, And George, we're told, is 2 feet shorter than the shadow. So if I let x be the length of the shadow, then George is going to be 2 feet less than that. So it'll be the shadow length minus 2. If you wanted to, you could also let x be George's height. And if he is x, then the shadow would be x plus 2. It doesn't matter as long as you have the appropriate relationship. You know, you don't have to worry about correctly saying, okay, I'm going to let this thing be x. It's just however it happens. Then you just need to make sure that everything else is defined as it should be. And we're also told that from the tip of the shadow, which would be here, to the top of George's head, which is here, that's 10 feet. So from here to here is 10. Okay, so there's my picture, and then I've worked through every bit of information. And so the assumption that needs to be made here is that George and the ground are meeting at a right angle. And if we do make that assumption, then what we've got going on here, we've got a right triangle and we've got the sides. So again, if you go back to your geometry, you know that for every right triangle, it is always true that using the Pythagorean theorem, that side squared plus side squared equals the hypotenuse squared. Okay? Or you probably have heard a squared plus b squared equals c squared, but I don't like to use a's, b's, and c's because that confuses people. But when you're talking about right triangles, the sides, those are the legs of the right triangle that make the 90-degree angle. The hypotenuse is the other one. Okay, so whichever two legs make the right angle, the 90-degree angle, those are your sides, and then the other is the hypotenuse. So we can use this Pythagorean theorem to write an equation that's going to let us solve for x. So my sides are x minus 2 and x. So it is true that x minus 2, quantity squared, plus x squared is equal to our hypotenuse squared, or 10 squared. Simplifying this, if you square a binomial, don't forget that you have to FOIL. You cannot just square the terms. So a binomial times a binomial, the x times the x, x squared, x times negative 2 minus 2x, negative 2 times x is negative 2x, and negative 2 times negative 2, we have plus 4, and then our plus x squared, and 10 squared is 100. Simplifying the left-hand side, combining any like terms, I have 2x squared minus 4x plus 4 equals 100. So it's a quadratic equation. I'm going to go ahead and get it equal to 0. So I'm going to subtract that 100 from both sides. So now I've got 2x squared minus 4x minus 96 equals 0. All of these numbers are divisible by 2. So I can go ahead and make this an easier equation to solve. Just divide both sides by that common factor of 2. So I've got x squared minus 2x minus 48 equals 0. And now the equation that I have, that's very easy to solve by factoring. That factors into x minus 8 times x plus 6. And so I get x can either equal 8 or negative 6. So if I go back to my setup and back to what x was, I let x represent the length of the shadow. So 8 feet or negative 6 feet, the negative 6 feet does not make sense. So that tells me then the length of the shadow must be 8 feet. And so if the shadow is 8 feet, then George must be 2 feet less. So George must be 6 feet tall. Okay? and that answers the question that was asked. So, as you go through, just a summary of some of the things I've been saying, when you're working with these problems, especially those that are geometric in nature, you want to make a picture, you want to label, the sides with some algebraic expressions based on the information in the problem. Once you have everything worked through, then you can go ahead and make an equation using the picture that you have, extra information, or just some previous knowledge. You're going to have to pull from some of your formulas to be able to get through this. Then once you have an equation, you want to solve it, and once you have the solution, you need to say, okay, what did I just find? And then you want to take whatever you just found and use that solution to answer the question that was asked. So you're going to have to think, and you're going to have to work your way through it. And so what you want to focus on when you're going through is not memorizing how to do each type, but try to give yourself this general process and try to work through the information, hopefully in a way that will work for you long term. So let me know if you have any questions. Good luck.